All right, everyone. Thanks for your patience. So please join me in welcoming Nir from DagsHub, who's going to talk about docking Jupyter Notebooks.
Thank you. And thank you so much, everyone, for waiting. I'm sorry for the technical issue. And I must say that this is awesome to see everyone here. It's been 2 wild years doing virtual conferences and finally seeing all of your faces and even some familiar faces that I already met during the conference. This is absolutely awesome, and I want to thank you for joining me today. And I'd like to start our session today by asking you a few questions. So we'll be more data-driven, the reason why we want to use Docker for Jupyter Notebook. So I'll start by asking, what type of operation system are you using? So with a show of hands, who is using here Mac OS? Whoa, okay, quite a lot, nice. I love it, though it gave me a few issues just now. What about Linux? Nice, wow, quite a few. Windows? Ooh, coding with Windows? How that's working for you? No, I'm kidding. I used to work with Windows, but then I discovered Mac, and coding with Mac, it's the best. So are you using any type of special hardware? Any specific, like powerful GPUs, very powerful clusters? Anyone are using special hardware here for training their machine learning models? Okay, I see quite a few. Nice. Awesome. So I'd like to ask all the people in this room, what do you think if I'm going to ask you to collaborate on the same machine learning project all together? Do you think it's going to be even possible? Well, probably it's going to be very challenging. You're going to have a lot of different dependencies, operation system that you're using. You're going to have problems like it works on my machine, but it won't work on your machine. And those are a lot of challenges that are hard to overcome. And by the end of this talk, we'll make it possible for all the people in this room to collaborate together on the same machine learning project together, regardless of their operation system or the tools that they're using, only by using Docker. So you're going to become a super woman or man of Docker. And this talk is going to focus on the very basic concepts of Docker. So what is Docker? Why do we actually need it? And what are the different components that it has? So if you are not familiar with it, by the end of this session, you will be. And if you are familiar with Docker and you know how to use it, this is going to be a very good refreshment for you. And my name is Nir Barazida. I'm an MLOps researcher at DagsHub, which is the GitHub for machine learning that does the DevOps heavy lifting for you. And in my research, I focus on machine learning workflows, which in my opinion has the perfect balance between machine learning, DevOps, and people. And when I'm off the clock, I do a different kind of heavy lifting. And with that, I think we're ready to start. So what is Docker? Docker is an open source software packaging tool for building isolated environment and running applications with their dependencies. So we're able to wrap our application, our project, to the OS level and run it on different machines without worrying on the dependencies that it has. It's one of the most widely adopted tools in the industry, and it's used throughout the development and production lifecycle of a project. And why do we really need Docker for machine learning? So generally, the main advantage that Docker provides is standardization. And this gives us, first and foremost, reproducibility, which is very valuable for data scientists. So everyone are using the same operation system, the same tools, the same dependencies, which means that if we want to reproduce previous results, we can do it very easily. We can simply use our Docker container to run it on a local machine and start building our model. And it also provides us the ability to move our application or our training of our model from one machine to the other. And if you can think about it, most of the people who are using or are training machine learning models use heavy computing power, so they do need to move their projects from their local machine to their remote cluster or to a powerful GPU machine. So this is very important. And Some of you might ask, why not simply use Colab for that task? Well, Colab does provide an isolated environment that has all the dependencies that you need for the rest of your team. And that might be a bit of a harsh slide, so I'm sorry for that, because Docker is good and it does provide some valuable capabilities. But when you're going to try to productionize your work and move to production, it's going to be harder because you don't know which operation system that machine use. If you and your teammate use the same machine, what tools you use. So it's going to take much longer to move from your research state to your production state. So that's why I wouldn't recommend using Colab when thinking about deploying to production. Okay, so we're ready to talk about Docker. And Docker has 3 main components that eventually creates that isolated environment. And I read a very good blog post written by our CEO, so I might be biased. And he compared building that Docker container, so that isolated environment, to the process of baking a cookie. It might sound funny, but I promise you that it will make a lot of sense in the next 2 minutes. So the first component that Docker has, it's the Dockerfile. And the Dockerfile is basically a file that contains all the commands that we want to call when we generate the Docker image, which is the next component. And it basically has all the commands such as copy or move files or run some sort of installations. So that file is going to hold all of those commands. And in our analogy, the Docker file is the engineer's instructions on how to create our cookie cutter for baking our cookie. So which height it should be, how strong it should be, etc. Next, we have our Docker image. And our Docker image acts like, and this is a very, very big like, so don't use it outside of this room, including the people watching back home. So the Docker image is like a zip file that holds all of the components of our project or all of our dependencies in it. So if you want to copy files that you have from your local machine to that Docker image, if you want to install the operation system that you want to use, Linux, Ubuntu, and more. And in our analogy, our Docker image is basically our cookie cutter that will create our Docker container. So basically, it has everything that we need in order to run our application with all of our dependencies. And last, we have our Docker container, which probably a lot of you heard about it. And Docker container is basically a single instance of our application that is live and running. And in our analogy, our Docker container is actually our cookie. So what we try to build through that entire process. And where does those container live? So container lives in a container registry, which is a special type of storage. And companies use different types of storages like AWS ECR, Azure Container Registry, and more. But there is another registry, which is the Docker Hub. And this is, you can think of it like the GitHub for Docker. And it has a lot of Docker images, so this is important. All of those registries are holding Docker images. And those images are available for the public use on Docker Hub that are for various types of tasks. So if you want one for machine learning or for running a Flask application, if you want to use Windows, Mac OS, different operation system, so you're going to find them all on Docker Hub. And now I think we're ready to get our hands dirty and start building our new Docker container from scratch for our machine learning project. And for that, I'm going to use my mnemonic classification project, where I try to classify X-ray chest images if they have pneumonia or not. So my DagsHub repository holds both my code and my data. My code is versioned by Git, and my data is versioned by DVC. And I'm going to pull all of it to my Docker container. And at this point, let's say that I'd like to test a new hypothesis. So I want to use a different type of backbone model. Instead of using ResNet, I'm going to use VGG19. So this is my new hypothesis. And for that, I'm going to create a new Docker. And I'm going to have all the dependencies I need to run that experiment on. So this is our goal here. Create a Docker container that I'm going to run my experiment on, which has all the dependencies that my team is using. So what will be the first part of that we're going to do? We're going to start writing our Docker file. And due to time constraint, I'm not going to cover how to install Docker. This is a fairly easy process. This is the only process that varies between operation systems. So there are different installation on Mac, Windows, and more. But this is should be very easy task. And I'm going to add a link at the last slide with a reference on how to install it. So by starting to work on our Docker file, we'll usually base it on a previous image that already has some of the base dependencies that we're going to need for our project, like the operation system that we'd like to use, the language that we'd want to use, which is obviously Python, some frameworks, so Keras, TensorFlow, PyTorch, etc. And if we're not going to base it on a previous image, we're going to have to write everything from scratch, which is going to be very hard to do, or it's going to be a very long process. So I highly recommend basing your image on previously defined images. So for my project, I will need the following dependencies. So I need Python 3 and above. I'm going to need Git because I want to clone my project to that Docker container. I would like to have a Jupyter Notebook and TensorFlow as the framework to use. So a quick search on Dockerhub, and voila. I have a Docker image that is maintained by Project Jupyter that probably a lot of you are familiar with, which are maintaining that image for TensorFlow with Jupyter Notebook and a lot of other dependencies that are relevant for data science, like pandas, NumPy, etc. And what do we actually see here? So first of all, we see the name of the maintainer, and then the backslash, and then the name of the image that we have here. So the name of the image here is actually TensorFlow-notebook, and this is important. Next, we can see how reliable that Docker image is. So we can see that it has 50 million downloads, which is fairly reliable. We can also see how we can pull it to our local machine. So let's say we don't want to reinvent the wheel, and we want to use that the exact image that already exists. So all we need to do is pull it to our machine, and we can start using it. Next, we're going to see here the tag. So the tags are basically the version of that Docker image. It will be updated as the dependencies are updated. So let's say TensorFlow releases a new version, then probably Jupyter Notebook or the Project Jupyter are going to create a new version. And you can see that there is a special type of tag here, which is the latest. And latest means the newest version of that image. Next, we can see the operation system that it used. So here it used Linux, and it has its 3.1 gigabyte weight. So let's take this information and put it in our Docker file. So for that, we're going to use the from command, which is going to state the base image that we're going to use. Next, we're going to state the maintainer backslash the name of the image that we'd like to use. And last, we're going to state the tag name. So here I used latest, but if you want previous versions of that image, you can simply specify it here. And by running that command, when I'm going to build the image, it's going to simply run the install command, and it's going to use the tag latest. And at this point, I would like to go ahead and go to my DagsHub repo and see what is my Git remote, my DVC remote, which is basically my remote storage, so I'll be able to pull all of my data. And where do I store my requirements? So I would like to also install all the relevant requirements for my project. So I'm going to take all of this information, and I'm going to put it in my Docker file. And here you see that I'm using the run command, which is basically going to run the following pipeline. And next, I'm going to clone my repo. I'm going to change directory to the project. I'm a true believer in using branches for testing new hypothesis. So I'm switching to VGG19 branch. Then I'm installing my requirements, and I'm going to pull all of my data. So this is going to be translated into this. And a few more commands that I think are going to be valuable for you. So we have the env command, which is simply going to set the environment variables. We have the copy, which is going to copy the files from our local machine to that image, so to that imaginary zip file, if you can think of it. We have the maintainers, so the name of the maintainer of the Docker image, and the cmd command, which is the default command to run after building the image. Next, we're going to want to run that Docker file and build our Docker image. So for that, we're going to use the Docker build command. We're going to use the pull flag, which is simply going to pull all the latest updates from the remote Docker hub. Next, we're going to tag it. So I tagged it as pneumonia classification, which is the repository name, and the VGG19, which is the hypothesis that I'd like to test. And next, I'm going to specify the path to my Docker file. And by running this command from your terminal, it's going to build a new Docker image. If it's the first time that you're using that base image, so the TensorFlow notebook image, it's going to download it to your local machine. Then it's going to run all the relevant commands, and it's going to wrap it up in that Docker image file. And now let's see all the files all the images that I have locally. So by running Docker images, you're going to see all the images that you have. And here I can see that I have the pneumonia classification and then the VGG19 with the Docker image. And now we'd like to run our Docker container and start working on our project. So for that, I'm going to use the Docker run command. I'm going to give it a name, so Nir, my name, the port I want to use, and the image that I want to base the Docker container on. So it's going to use the pneumonia classification VGG19. You can also specify here the Docker image ID, and it will also work. And by running that command, I'm going to see in my terminal the same thing that I see when I run Jupyter Notebook from my terminal. So it's going to simply run the Docker container, and it's going to provide me with the URLs that I'm going to need to copy to my browser in order to get the Jupyter Notebook environment. And by copying one of those URLs, I'm going to get a fully configured Jupyter Notebook environment with all my project dependencies and files. So this includes both my code files and my data files. So basically everything that I need in order to start testing that new hypothesis. And let's say that at this point, I changed a few lines of code, I ran the experiment, and now I'm ready to version it and push it to my Git and DVC remote. So I want to push both my Git tracked files and my DVC tracked files. So for that, I'd like to connect with an SSH to that Docker container. And how can we do that? So we're going to use the Docker X command, which is going to execute that command. We're going to get an interactive terminal. And then we're going to take the Docker container ID that we'd like to connect to, and then the command that we'd like to run, and how it's going to look like. Then I'm going to start by looking for all the containers that I have live. And from that, I'm going to take the container ID that I'd like to connect to. Next, I'm going to run the command, the docker execute it, and then I'm providing it the container name. And last, I'm going to open a shell script in that container. And as you can see, I'm inside my running container. Next, we can simply run or change directories, run git status, version our code, and push it to our remotes. And as simple as that, you can start building your machine learning project on an isolated environment with your colleagues without worrying about issues with dependencies or using different types of tools. And by pushing all of those files, I can see that experiment on DagsHub and compare it to different experiments. I can diff my Jupyter Notebook and see which cells I modified, what was the output when I modified it. So if I process my data differently and how what was its output, etc. So reaching to the end of our time together today, I'd like to have a quick recap on what we covered. So we started by talking about why do we actually need Docker for machine learning, and we understand that this is very valuable for us to collaborate and reproduce results with our colleagues. Then we talked about the different components that Docker has. So we have the Docker file, the Docker image, and eventually we have the Docker container, which is a live app that is fully configured and running. And last, we saw how we can build our Docker container from scratch. I'd like to ask you if you have any questions. And before you are going to infer it, I'm going to state one question that I didn't cover. So how you can share that image that we just created with your colleagues. So because of time constraint, we can't cover it today, but it's a fairly straightforward task, which is kind of like Docker push. It sums to Docker push. You simply need to set your credentials with Dockerhub and push it to your Docker registry. Once again, I added a link on how to do it in the last slide, so you can easily do it. And if you have any questions, I'd love to take them. I think we have a minute, or you want to take it offline?
Actually, everyone, sorry for the confusion. We can't take questions
Okay.
in the room due to COVID restrictions, but feel free to come to the front and ask them directly.
Awesome. So we're going to take it offline. So I'd like to thank you all for joining me today. It was awesome. It's so great to finally do live presentations and live talks and seeing all of your faces here. It actually warms my heart, so I'm very excited. And thank you so much for joining.